This is the HEC Project HD-3 instructional video. I want to start off noting that the contours outside of the pavement for NC 125, Loop A, and I-95 are optional. You'll see that at the bottom of your instruction sheet, but it doesn't exactly stand out, so I wanted to point that out first. Only the contours within the pavement of NC 125, Ramp A, and Loop A, as well as the contours outside of Ramp A for the ditch and shoulder, are required. If there is anything that you're unsure of when you're completing this project, please refer to this example drawing. So we're going to start with NC 125 first. The first thing you need to do is pull the 2-foot contours from your vertical alignment profile, which is what you can see here. And what you can do is go ahead and pull those 2-foot contours for all of these roadways. I would put them in a table if I were you, just to know, so that you know where the 2-foot contours are and where the stations for those contours are. As stated in the instructions, you may want to pull the 1-foot contours where there are vertical curves for each of these, for Loop A, Ramp A, and for NC 125. But I will continue in this video only discussing the 2-foot contours for the sake of simplicity. Lightly mark these points at the appropriate stations along the horizontal alignment. So for now, let's just do NC 125. You'll do the same thing with Ramp A and Loop A, but for now let's focus on NC 125, and then I'll point out a few discrepancies from Loop A and Ramp A compared to NC 125. When you're marking these points at the appropriate stations along the horizontal alignment, be sure to mark them along the center line, as that's what you have drawn for these vertical alignments. So that would be the only location where those points would be appropriate. So mark them there, and be sure to kind of lightly draw in what each point is, if it's the 152 contour, if it's the 160 contour, so on and so forth, so you'll be able to reference these later and not have to go back and try to remember what each contour point is. Then lightly sketch a line perpendicular to the center line, starting at the elevation contours you just marked. They're going to be really hard to see on this example drawing, but you can actually see a little bit of green here. So the point where the green lines meet is the point that I'm talking about marking. So mark that point, but the line that you're going to draw, I want you to very lightly sketch a perpendicular line. You can see these lines are not perpendicular, but lightly sketch a perpendicular line to the center line, starting at the elevation contour you just marked. Once you've drawn these lines that are perpendicular to the center line, that extend to both edges of pavement, I want you to measure the distance from the center line to, we'll say, the right edge of pavement over here. If you're going northbound, it's the right. And I want you to do that for each one, and I want you to then measure the distances from the center line to the left edge of pavement as well. And I want you to, the distances that you measure, I want you to mark over top of each line. So when you measure from one side, from the center line to one side of the road, I want you to mark that distance so you don't forget it. On top of that line. Don't put it on a separate sheet because you'll forget which one's which, but mark that distance lightly on top of that line, and then do the same thing. Measure the distance from the center line to the other side of the pavement and mark that distance also, as you're going to reference those in just a moment. After you've done that for each one of those contour points that you've drawn along the center line, I want you to measure the distance between those contour points on the center line. So not necessarily on the edge of pavement, but just along the center line. I want you to measure the distance between the points that you've already drawn. You can probably pull those points from the stations that you have for these contour points. You can get that distance that way if you'd like, but I would it's just as easy to lay down the scale and and measure this distance, and then I want you to mark that distance also, probably we'll say halfway between each contour point that you're looking at, that you're measuring between. Go ahead and write down that distance because you're going to reference that number in just a moment as well. You're told in the instructions that the cross slope for NC 125 is 0.02 or is a 1/4 inch per foot, which is the same thing as 0.02, which is normal crown. You want to take those widths that you measured and you wrote down from the center line to the edges of pavement. Take each of those, don't combine them. Take the one that's on the left side of the center line and the one that's on the right side of the center line, and multiply each of those numbers by 0.02. And whatever you get when you do that calculation, I want you to write that number above the pavement width. What you're finding is the vertical distance from the center line to the edge of pavement where that perpendicular line intersects. So essentially what you're finding is, if you're, let's say we're looking at say this contour line here, if you had that perpendicular line sketched across, you'd have an elevation for the center line. That's going to be a whole number. Say, I think this one looks like it's I can't tell, 152 or 162, something like that. Whatever number it is, you're going to have a whole number for that point on the center line. But what you're finding is the difference between the center line elevation and the edge of pavement. That's why you had to do each side, because you can see the pavement width, even though this is the center line, you can see because of the taper and the turn lane that the right side of the road is wider than the left side of the road. So you're finding the elevation distance change from the center line to, say, where that perpendicular line intersects the edge of pavement here, and you're finding the vertical distance change over on this side of the road too, and you're finding it for each one. So maybe above the pavement width that you have written down, write down that number on each side of the road as well, because you're going to use those numbers to interpolate to find where these contour lines actually slope down, to see where the actual whole number contour points are going to be on the edge of pavement. An example of this calculation is shown on the second page of the HD-3 Contours Example PDF. If I pull that up here. So here's the second page. You can see this. You can see the numbers here of the center line. This is actually the center line where you see CL. This is for ramp A, by the way, but let's refer to it as though it were NC 125 for now. So you can see you've got your 152 contour points marked on the center line. What you're finding is this 151.76. So the way they got that is, let's say that the width of the lane here, or from the center line to the edge of pavement, let's say it was 12 feet, just to have an easy standard number to work with. That's obviously going to vary, especially on NC 125 with the tapers and turn lanes opening up and whatnot, but we'll use 12 feet for now. So if you did 152 minus 12 feet times 0.02, that's going to give you 152 minus 0.24, which is 151.76. So again, this dotted line here is perpendicular to the center line, so that's giving you the edge of pavement elevation across from that center line elevation. So it's 152 here, so it's 151.76 here. Again, note this is ramp A, but we're going to be talking about NC 125, and I'm going to refer to this 152 and 151.76 often just as an example calculation, but obviously this is going to vary depending on if you're working with ramp A or loop A or NC 125, and the pavement width is going to vary and the cross slope is going to vary and stuff like that. Now do the same thing for each contour line and perpendicular line. So this dotted line, if that's what you're thinking of it as on your drawing on NC 125, do the same thing for each of the contour lines and the perpendicular lines, so that you will not only have the center line elevations, but also the elevations of the edge of pavement perpendicular to the center line. So you'll have this 151.76, 152, or 153.76, and so on and so forth. So do that for each contour point that you have. And that's going to vary. It's not always going to be just 0.24 different, because like I said, the pavement width is going to be different even just along NC 125. Now we're going to use these centerline and edge of pavement elevations to get the whole number 2-foot contours along the edge of pavement. Meaning instead of just this 151.76, that doesn't do you a whole lot of good when you're looking at it on the drawing. What you want to see is these solid contour lines. So we want to find this 152. Where is the 152-foot contour going to meet the edge of pavement on NC 125? Use the equation you see on the second page of this HD3 contours example PDF and on the second page of your instructions to find the distance between the edge of pavement points with known elevations and the whole number of contour points you're looking for. In other words, the distance between this 151.76 point and the 152 point that you're looking for can be found using this equation here. So we're going to use that, and it's actually also on the second page of your instructions. If I pull that over, you can see this is kind of an example. They're using different numbers than what I use with 152 and 151.76. They've got 156, 155.76, 157.76, so on and so forth. But it's going to be the same process. So if I'm just working with what I see here, if I'm using 152.76, 151.76, and 153.76, I can find where this 152 is going to come in. If you're looking at this equation, continuing with the same numbers we've been using, these 152 and so on and so forth, the variables in this equation would be as follows. So elevation A for point A would be 152. Elevation B that you see here and here would be 151.76. You can see it's marked B there. Elevation C here in the equation is 153.76. And the distance D is the distance you found between the contour points. It's going to change between each one. It's not going to be the same between each one. That's why you had to measure each one. For this one is 65 feet. L is the distance we want to find because that's going to help us know where to mark this point E, I guess is what it's being called, which is where the 152 contour point falls on the edge of pavement. So when you plug all of that into that equation, you can find that L distance to be about 8 feet. I think it comes out to 7.8 or something like that. You don't have to, you're not going to measure tenths of a foot, so just go ahead and do work with easy whole numbers for feet, and that's going to be sufficient. So, and again, that will give you where that 152, in this case, crosses that line. Then you can move up to 154 and find where that crosses the edge of pavement, and so on and so forth. Note that if you're referencing the 151.76 foot point, you'll go in the direction of increasing elevation to find the 152 contour point. In other words, the 152 point will be between 151.76 and 153.76, obviously, which is shown on this example. So 152, in other words, would not be down here below this 151.76 because it has to go in the direction of increasing elevation. Also note that you'll want to keep track of which contour line is which, so make sure you leave the labels on the contour lines for now. So where you've got marked 152, 154, 156, 160, so on and so forth. Make sure you leave those marked there at least lightly because you're going to need to reference these, obviously, to find where they go and what the actual number is going to be on the edge of pavement from the perpendicular line, and then to go from there to get to where the whole number contours are. You're going to need to know those elevations, so don't erase those just yet. And you can now follow these steps that we just did to find all of the edge of pavement whole number contours along NC 125. So do the same process as you can see they did here to find this point, and then so the 154 contour, 156, 158. Obviously, you're going to be working with different elevations and whatnot, but use that same process that we just did to find that one. Use it for each one of the contours. I know you're probably all stressing right now about that because that is going to take a little bit of time, but there's not as many contours as I think you're expecting, and you should already see that on your drawing. There's not like 40, 50 contours just on NC 125. There will be a few once you get done with doing all NC 125, ramp A and loop A, but don't fret just yet. Just use the numbers that you've done, and it'll become kind of routine. It'll become easy, so it won't take as long each time. After you've found all of these points, so the whole number elevation contour points along the edge of pavement, connect the dots between the appropriate contour points by drawing a straight line between the two, because the NC 125 horizontal alignment is straight. For example, the center line of the edge of pavement and the edge of pavement 152-foot points will be connected by a line, as will the 154-foot points, and so on and so forth. So you connect the dots between the 152 points, you connect them between 154, 156. Like I said, your elevations on NC 125 I think are closer to 160, but same thing. And at this point, you'll have all of the contours within the pavement on NC 125. So now we're going to move on to the shoulder contours for NC 125. Again, I want to point out that this part is optional, but I'm still going to go over it for now. You can skip ahead if you would like. Note that we're only drawing the shoulders on the east side or the south side of NC 125 also, not the other side as shown in the provided example. So when you look at this, you can see there's no contours on the north or west side, I guess you could say, of NC 125, just on the east side here. For NC 125, you're told that the shoulder is 8 feet wide and has a 1/2 inch per foot cross slope, which is the same as a 0.04 cross slope. You know, inside the pavement is 0.02, so for the shoulder is actually going to be 0.04 to the shoulder point. You can actually see the shoulder point in this drawing. You can see where the slope changes. The slope of the line, that is, changes from the edge of pavement to here. That is that 8-foot offset. So you should already have that drawn from last week, I believe, but if not, you can draw that now. Just lightly sketch an offset line that's 8 feet wide for NC 125. It's going to be a different width shoulder for ramp A and loop A, but for NC 125 it's 8 feet. So I'm going to go back to this contours example because that's going to be easier to reference than trying to see those hard to see points on the example drawing. Using the same method you just did to find the edge of pavement elevations, find the edge of shoulder 2-foot contour points along the shoulder point and connect the appropriate contour points. This should be slightly simpler, I want to point out, than the pavement contours, as your shoulder width is uniform throughout, so it's not going to change. The width of the shoulder is going to stay 8 feet instead of varying throughout the length of the NC 125. You can see here, again, note that this is ramp A is what is shown here. So it's showing a 6-foot shoulder. Again, that's different from NC 125. Less, I guess, for the sake of simplicity, let's refer to this as though it were NC 125 and this is an 8-foot shoulder. So the equation you would use to get, for instance, this 153.76, I think right here, which is going to be different for NC 125, but you would use the equation 8 feet times 0.04, which is your cross slope across that 8-foot shoulder, which is 0.32 feet. Now you're going to subtract this number from each contour point you're referencing to get the elevation perpendicular to each contour point on the edge of pavement. So that's what this dotted line is here again, is just a perpendicular line from the edge of pavement to the shoulder point. So at the 152 point on the edge of pavement, which is here, which is this point E down here, draw a line perpendicular to the edge of pavement until it meets the shoulder line. So you draw a dotted line or whatever, a sketch a light line that comes across here to the shoulder line. And that shoulder line should be lightly sketched as well, because you're going to have to erase that. This is going to make the point where these two lines intersect, so where that dotted line comes across to the shoulder line here, would be 151.68 feet. That is if, again, it were an 8-foot shoulder, not a 6-foot shoulder. So it's going to be 152 minus 0.32, because that's 8 feet times the 0.04 cross slope, which is 0.32. So 152 minus 0.32 is going to give you 151.68 would be this point here if there were a line drawn perpendicular across here. Now we're going to move on and draw the slopes beyond the shoulder point. So you do that same process for each of these, for each of the shoulder points on NC 125, and after you've done that, now we'll move on to the shoulder point, the slopes beyond the shoulder points. As a hint, there's no ditches on any of the roadways except for ramp A. So although you're provided in the instructions with the front ditch slope for NC 125 and Loop A, that would only be if there were a ditch, and there is not in this case. You can actually see that here. You can see the ditch points here along ramp A, but there are none like that for NC 125 or for Loop A, except where the ditch meets here, which is really just the contour lines meeting the ditch point for Loop A. There, but otherwise there's not going to be any ditches. With that said, we're going to draw fill slopes for NC 125, which are provided as having a 2-to-1 slope away from the shoulder point. Now this is a really steep slope, fill slope, as the existing ground had a much lower elevation than the new NC 125 alignment, meaning a lot of fill dirt will be used to achieve the appropriate elevations for NC 125. So if I come in here, you can actually look and see, obviously the existing ground is further and further away from the new pavement and the new alignment here for NC 125. So you can see there's going to be a lot of fill dirt. And again, it's going to be really steep. You can see how steep this slope is by looking at the example drawing here and observing how close the contour lines are south of Loop A. So here's Loop A. So south of that, you can see these contour lines are really, really close. That just means it's a really steep slope here on this portion of NC 125. These contour lines south of Loop A will turn below the bridge down here, but we're going to get to drawing those in a second. North of Loop A, the contour lines will be steep, but not as steep because these sections, this section of NC 125 will be closer in elevation to the existing ground, and these contour lines will simply merge with the existing ground contours as shown in the example drawing. So you can see here, you've got these steep contour lines here for the fill slope, but they're just going to meet down here with the example, with each of the existing ground contours. And you'll know which one they meet with based on which contour line you're working with. So if you were at the 150 contour line, I can't read these off of this page, but or 156 we'll say, 156 is going to pass this, whatever this is, 154, or no, that is 156. So 156 is going to pass that line there and meet down here because you need to have that fill slope. And obviously, even though this is 156 and they cross each other, that's the existing ground and it's not going to be there anymore. You're going to have fill dirt that's going to fill in there. So the best way to accomplish drawing these fill slopes is to pick an arbitrary fill slope width that you're going to extend beyond that width, but it's going to help you to just pick a number and mark some elevation points out here beyond the shoulder point and find the 2-foot contours in the same manner that we found them so far. I'm going to use 8 feet of fill slope width because it's an easy number to work with in terms of the slope ratio that we're using. So it's a 2-to-1 slope, which means that for every 1 foot of vertical change in elevation, the horizontal distance change is 2 feet, as shown in your HD-3 handout PDF, meaning that for 8 feet of fill slope width, the change in elevation is 4 feet. You can kind of see that here. This is not at all drawn to scale, but do note that it changes. 6-to-1 is a little flatter, 4-to-1 is a little steeper, and 2-to-1 would be a lot steeper than 4-to-1. This is going to make your numbers easy to work with, but note that 8 feet may be too wide for the fill slope width when you're looking at this example here. Hopefully not, but we're going to use 8 feet just for simplicity's sake. So again, for 8 feet of fill slope width, the change in elevation is 4 feet. What this means is measure 8 feet perpendicular to your shoulder point. So this point here is a little hard to see, but where that line breaks there and there and there and so on and so forth, measure 8 feet perpendicular to the shoulder line you should have sketched in still. Measure 8 feet perpendicular to that shoulder and mark this arbitrary point. This point will be 4 feet lower in elevation than the perpendicular point. For example, if we continue with the 152 example that we've been using, the 152-foot contour point, a point perpendicular to your 152 point on your shoulder will have an elevation of 148 feet. So lightly mark this on your drawing. So if we're looking at this example here, let's say this is 152 right here. Again, this is a ditch because this is ramp A. That's why we have this one drawn as an example, because that's going to be different than just meeting existing ground on like you would on NC 125 and Loop A. So pretend that ditch is not there and that these lines beyond the shoulder point just meet existing ground. So if we have 152 here and the width here was 8 feet, and we drew a perpendicular line across here. Again, measure at 8 feet and just mark a point that's perpendicular to your shoulder point. And then this point here would be an elevation of 148 feet. Because it is a 2-to-1 slope across 8 feet, then that means there's a 4-foot difference in elevation from here, which is 152, to here, which is 148. Do this for all contour points along your shoulder line so that you'll have points you can connect to your shoulder contours. So once you have all of the different contour points drawn for this arbitrary, again, we're pretending this is an 8-foot offset line here from your shoulder point to get your fill slope. Once you have all of those points marked, then you can just draw a line to connect the dots. So the 152 dot on the shoulder will meet your 152 dot on your fill slope, your arbitrary fill slope line. So you would draw that, and then you would just extend beyond that, going in a straight line until you meet the existing grade contours. So you'll see that here. Essentially, we would have points marked like here, maybe here, so on and so forth, just arbitrary points, and then you would just continue that line straight until you meet the existing grade and kind of curve into that existing grade just slightly. Now we're going to skip to ramp A, and then we're going to come back to loop A, because loop A is slightly more difficult than NC 125 and ramp A. So for your ramp A pavement contours, let me come down here to ramp A. Draw the contours within the pavement of ramp A similar to how you drew them for NC 125, except for ramp A, the contours will slope in the same direction across the entire width of pavement, from left to right. or in other words, from the outside of the curve, which is this left side if you were exiting the highway, to the inside of the curve, which is the right side. Again, you're going to start though from the center line and go to the right side, but when you come back to the left side and draw that line, that's going to go the opposite direction from what, or it's not going to be quite the same as what you did for NC 125, because that contour line is going to be going the same direction across the entire width of the pavement for ramp A. Now we'll move on to the shoulders of ramp A. There's a 6-foot unpaved shoulder on each side of ramp A as compared to an 8-foot shoulder on NC 125. So offset a line 6 feet if you haven't already from the edge of pavement. Again, sketch this lightly because you're just going to reference this. It's just going to assist you in knowing where the shoulder contour lines stop and transition to your ditch contour lines. So sketch that line lightly. That would be where these points are, not these sharp points that you see. That's the ditch point. But where these start to turn here as they leave ramp A, as they leave the edge of pavement, where those points are, that would be where you've got a light line sketched for your 6-foot unpaved shoulder. You're going to draw these shoulder contours the same way you drew your shoulder contours for NC 125. Be sure to reference this drawing, this example drawing for help if you need it. Now on to the ditch contours for ramp A. The difference between ramp A and the other two contour layouts, so for loop A and for NC 125, is that ramp A has a ditch that has a low point that's 18 feet from the shoulder point, not 18 feet in elevation, but 18 feet. It's an 18-foot offset line from the shoulder point that we just drew the contour lines for. So lightly sketch a line offset 18 feet from the shoulder point on both sides of the roadway. You can continue that throughout the entire length of the ramp, although the ditch isn't going to extend quite all the way down both sides. It will on the left side, but not on the right side. The slope from the shoulder point to the bottom of the ditch is a 6-to-1 slope for 18 feet. So for this 18-foot offset, meaning that if you draw a line perpendicular to the shoulder point from the ditch, from the shoulder point and the ditch bottom, the point intersecting that line on the shoulder point will be 3 feet higher than the point where this line intersects the bottom of the ditch. So if you have a line, if you have your shoulder drawn here, your shoulder line lightly sketched in, and then you have an 18-foot offset line down here, if you drew a line that was perpendicular to those, again, you can do it as a dotted line if you want to, as shown in the HD-3 contours example PDF. But if you draw a line perpendicular, same way we've been doing so far, then let's say this is the, I can't tell right off the bat which line this one is. Well, let's say this one. This is the 156 contour here, and this is 154, I believe. So from 156, if you draw a line over to, you can almost see it here actually for the bottom of this ditch. That's what this sharp point is. That's the bottom of the ditch, not the other side of the ditch. But if you draw a line perpendicular there, if this is 156, then where that line intersects here, so from the shoulder here, 156 to here, it's going to be 153 feet because of that 6-to-1 slope going for 18 feet. Again, the ditch travels almost the entire length of the ramp, which means you can disregard the information about fill slopes, except for on the right side at the bottom of ramp A, where you'll see on the example drawing that the ditch transitions to a fill slope beyond the 140-foot contour. So you can see this ditch gets smaller and smaller. The distance, the length of those contours gets smaller and smaller until you get to the 138 contour line. So up to 140, that'll still be a ditch line. But at the 138 contour line, the new contour lines will tie into the existing contour line. So you'll see they, for 138, they just tie into the existing ground, 136, 134, 132, so on and so forth. This is because the ditch is no longer needed, because the fill slope that was used to build this ramp is steep enough and long enough to drain the water away from the roadway, so you don't need a ditch. Where the ditch is present, the contour lines will tie back into the existing ground with a 4-to-1 back slope, which is similar to what we did previously with NC 125. If I zoom out here, you'll just pick an arbitrary point and draw a 4-to-1 back slope and just continue that line in a straight line. Well, it'll curve a little, you can see here, but continue that line until it meets the existing ground contour lines. Now we're going to take a look at the Loop A pavement contours. They're going to require a little more thought than what you've had to do for NC 125 and for Ramp A, as the cross slope of the pavement is constantly changing through the two spiral portions of the curve. So between the TS and SC stations and between the CS and ST stations. I don't have them marked here, but I believe you'll still have them marked on your drawing. So between those stations, the TS and SC, and between the CS and ST, the cross slope is going to constantly be changing. So it's gonna not be quite as straightforward, but give it your best shot. Between the TS and SC, as well as between the CS and ST, the cross slope on the pavement will vary from 0.02 to 0.08, with the cross slope at the TS, so at the start of the spiral, and at the end of the spiral, the ST stations being 0.02. So actually at those points, and the cross slope at the SC and CS stations, so where the spiral transitions to the curve and then where it transitions out of the curve back to another spiral, at those particular stations, the SC and CS stations, it's going to be 0.08. As 0.08 is the slope of the simple curve portion, so between the SC and CS stations, 0.08 is going to be the slope of the simple curve portion of the loop. You'll not be able to draw this perfectly again, so don't get hung up on this portion of the contours. This is why I skipped this portion of the contour drawing and did Ramp A contours first. Even though that's not how it's shown in your instructions, I just knew Ramp A was going to be simpler to draw. As noted in the instructions, there's curb and gutter on the inside of Loop A. So on this side of it, the right side, if you're driving down and entering I-95, and this curb is 6 inches tall above the pavement surface. You can see this when you're looking at the example drawing and noticing that the contour lines don't meet at the edge of pavement. So the contour lines inside of the pavement don't meet the ones that are inside of the curve on the ground here. They do not meet each other. So this is the 156 contour. It does not meet the 156 contour inside of the pavement because of that 6-inch curb. Note that these are 2-foot contours, and the 6-inch curb height can be drawn by figured by interpolating between two adjacent contour lines. And drawing them a quarter of the distance down from the higher contour to the adjacent contour that is 2 feet lower. So if I'm looking at say the 158 contour in the pavement that I've already drawn and the 156 contour here, if I want to know where this contour line starts outside of the pavement, I would find the distance between these two and go a quarter of the way down, because 6 inches is 1/4 of 2 feet, and that's where that would start. Once you've found these outside, the point outside of the edge of pavement where the contour lines start, draw them over to NC 125, meeting at this 2-to-1 fill slope here that we had earlier in the instructions for NC 125. This 2-to-1 fill slope means the contour lines will be 4 feet apart since they're 2-foot contours. So if you had a scaled version of this drawing printed out, you could actually measure the distance between each one of these contour lines, and it's going to be about 4 feet. They're going to be a little bit off. You can see some of them are slightly different, but it's going to be pretty close to 4 feet because they're 2-foot contours and it's a 2-to-1 slope. When all else fails, when you're trying to draw these in and you want them to look pretty, draw them similar to what you see in this example drawing. They're going to curve slightly because the hill's going to curve a little bit. And as far as the contours on the outside of Loop A, so over here, There's a 6-foot shoulder on the outside of the curve that has a .04 cross slope. So if you drew a line offset that's 6 feet offset from the edge of pavement on the outside here, that would be your shoulder line. Again, lightly sketch that because you'll see it's been erased here. But that'll show you where the shoulders meet, where the contour lines meet from the edge of pavement to the shoulder. And it's a .04 cross slope, so do it the same way you've done the other ones. And beyond this shoulder point on the outside of Lupe, draw the contours on a 4-to-1 slope until they meet the existing contours as shown in the example drawing. So just pick, again, an arbitrary distance, draw a line, and just make it go straight until it meets the existing grade. Or existing contour line. So here this one's going to be a little different because this 152 never crosses Lupe. And these down here as well, 150 and 148 will be slightly different, but you can follow the same example that you've got here in the example drawing. You can see up here when you get to 160, 162, they actually do meet the ditch. Even though that's not technically the ditch for Lupe, they are going to meet with that ditch instead of meeting the existing ground contours. So now we'll move on to I-95. So for I-95, you're only going to draw the contours that turn from the NC 125 fill slope here. You're only going to draw them that turn onto the slope under the bridge. The slope under this bridge is going to be a 1-to-1 slope, so the contour lines are going to be 2 feet apart now instead of 4 feet here, since they're 2-foot contours. So don't worry about drawing the shoulder contours beyond just that portion along I-95. And again, this is also optional actually, but beyond that, even though it says it provides the information for shoulder contours for I-95, it's not shown here in the example drawing, so don't worry about drawing that. For the final layout colors, you can see here there's red and yellow and green and blue and all of that. For those colors, see the list of colors at the bottom of your instructions, which you can see here. And note again that the contours outside of the pavement for NC 125, for Lupe and for I-95 are optional. Only the contours within the pavement of NC 125, Ramp A, and Lupe, as well as the contours outside of Ramp A, are required. Good luck.